Welcome everyone to the 6th event in the Algorand Educate series. Today we're joined by Ryan from the Algorand Foundation, as well as Russ, who's going to be helping out on some of the Q&A. And today is a session on building Algorand-Enabled dApps using AlgoSigner. So I'll hand over to Ryan now, who's going to lead the presentation today. If you have any questions throughout, be sure to put them in the chat. I'm sure Russ will help out, and also Ryan will take some of them live as well throughout the talk and also at the end. And just this event is being recorded, so if you miss anything or want to look back, just be sure to look at the Encode Club YouTube channel tomorrow, and it should be uploaded there. But over to you, Ryan.
Great. Well, thanks very much, George. I'm really happy to be here. Good afternoon, good evening, good morning, wherever in the world you are. Thrilled to be here with you. I am Ryan Fox, and I'm a developer advocate here at Algorand. I work for Algorand Inc. as opposed to the foundation, but we work together to make sure that we can bring you events like this here. Algorand Educate is something that we've been working on for now 6, and we are having a couple more upcoming as well. So be sure that you check out all that old content. A lot of the stuff that I'm going to go through today will build upon that. So I want to make sure that you guys have everything you need to build and to design, build, and deploy a new dApp. So that's what we're going to try to focus on today. I am thrilled to be joined by my colleague, Russ. He is going to be in the chat room and is going to be watching that as I go through on this screen over here and go through code and do all of the presentation and so on there. So he'll be watching that chat, making sure that he's answering questions, pasting in links as we're going through, and make sure that we're leaving time at the end. I'll go for the better part of an hour, but I will be sure to have some time left for us to have some questions as well. So I am working very hard to share my screen here and double clicking on it. And now I'm going to actually bring up the presentation. And so, Russ, we're all good?
Yes, sir.
All right, wonderful. Once again, end of the slideshow. Well, that's not what we want to be. Well, we'll get to see what we're going to see. All right, here we are at the beginning. Welcome, everyone. I'm Ryan Fox, developer advocate here at Algorand. I'm thrilled to be here with you. All right, this is what we're going to do, and why we're here is to get you guys focused on building your own dApps and deploying them in Algorand. And what we're going to do is take a quick look at AlgoSigner, get an introduction to what that is. It is similar to MetaMask if you're familiar with the Ethereum ecosystem. And then after that, we're going to get into an example dApp that I have that incorporates some NFTs as well. It's actually a mirror of something that's actually on the live mainnet, so that'll be kind of fun. And we're going to really focus on trying to get that interactive user experience inside of the browser, making sure that we're tying that back together with AlgoSigner. So let's get into understanding what is AlgoSigner. So AlgoSigner, first and foremost, is a non-custodial, very important, non-custodial wallet extension for the Chrome web browser. That means that this piece of software is installed into the Chrome web browser, and it holds your private keys. It has the ability to both create and import accounts, either existing accounts using your mnemonic or creating them brand new, and then they are stored therein. It is primarily a transaction signer, so that's what we'll see today, is integrating it into a website and then being able to have, as the web developer, the unsigned transactions presented to AlgoSigner. It will pop up, the Chrome extension will pop up, and it will present you with the unsigned transaction, which you'll take a look at and then sign it if you want, or you'll reject it if you don't want that one. And then most important, well, maybe not most importantly, but also very importantly, the fact that the AlgoSigner software is open source. It was produced and is maintained by PureStake, and they received a grant from the Algorand Foundation, well, a year and a half ago, I suppose it was, if not more, to go and build this out. And we're thrilled with the product that they've created for us here. AlgoSigner, you'll see a couple of screenshots here. We'll go and look at it momentarily. This is what we're going to do. I'm gonna teach you guys how to create an account, import account, and move through some of the other pieces. One of the great features is that it can connect to a sandbox infrastructure now. So by default, it knows how to talk to both mainnet and testnet. And as a developer, you're probably going to want to know how to focus on this screen, and we'll see how to connect it to our testnet as well. All right, so let's get into what that looks like then, shall we? Okay, we'll move this out of the way. And AlgoSigner, right. Here we are. If you go over to PureStake, you can understand what it's about. They've got a nice explainer video that talks a little bit about it. You would simply come here and click on Add to Chrome. It's very easy. That will take you to the Chrome web store where you can download it and install it into your web browser. What that looks like is here, and it's a little small. I can't make it any bigger. I apologize. This is what AlgoSigner looks like once it has been installed. The main pieces of this interface are going to be your accounts that you have installed to it. I have 3, Alice, Bob, and then I have this this creator account. We'll talk about that one later. And it has the ability to connect to different networks. So by default, it knows about mainnet and testnet, and I have created one for sandbox as well. And I want to make sure that we understand how that works. So under that little gear here to get into settings, you can see the network configuration. So mainnet and testnet, those are locked. Those are built into the extension itself by the maintainers, so that is just going to work. Then I have clicked on this new network button here to create my sandbox, right? You can type in whatever you want, and you will put in all of the information that you need here. And then depending on how your network headers are for your particular box, you would put all of that information in here. You can connect to both an AlgoD node, and you can also connect to an indexer. And then you would save that, and then you would have that. But I don't need to do that because I already have it, and you can see what that looks like here. So this is what it looks like fully configured. All right. All right, so I use this quite a bit when I'm working on the testnet. I will connect my sandbox is oftentimes connected to the testnet as well. So this, and if you're running your sandbox as a private network, you can also configure it to connect to that instance as well and get all of your private net transactions just the same. So that's nice. We're going to focus here on testnet because that's where my demos are at today. So let's take a look at, you see these 3 accounts here, but let me show you how you could actually do this brand new. So if you are coming as a brand new user, it would be empty, and you're presented with the opportunities to create or import an account. If you want to create an account, you can do that, but it's very important that you remember, store, write down, keep safe your mnemonic, because if not, your funds will be lost forever. So for Charlie, he's presented with 25 words here, and we need to scribble them down and maintain them someplace securely so that we can have these assets in the future. Tells us what our public address is that are corresponding to this private mnemonic here. Once you have written all of those down, you can continue, and then you are prompted to confirm all of those words in the right order. And once you do that, you can continue. And of course, I didn't do that, so I won't be able to create a new one. So the other opportunity is that you can import an existing account. So what that would require would be that you would have a mnemonic. And we can get a new mnemonic if we use a little command line tool called Algo key generate, right? So this little program right here, if we run it, will actually give us a brand new mnemonic. And it actually tells us what our private key is as well. So if we type in those 25 words in that order, we are expecting that it's going to start Indigo 5 alpha. And if I put in my password here, it will in fact make an account called Charlie. And if we click on Charlie, we can click up here on the ellipse and we will notice that it is Indigo 5 alpha as it indicated down here. So we have successfully imported this. This would be exactly the same process that you would use if you wanted to recover any of your mnemonics. You can import any mnemonic into AlgoSigner and have it work here. That's just fine. Okay, so as you can see here, by default, Charlie, he doesn't have any algos, he doesn't have any assets, he doesn't have any transactions. Well, that's of course because we just made it brand new. So let's take a look at some of the basic functionality that AlgoSigner also incorporates here, which is the ability to send transactions around. So if we get in here to Bob, we notice that he has 93 algos, and we would be very nice if Bob would like to send some algos to somebody. And that somebody, how about if we just do that brand new one that we just made down here, copy that, paste that address in here. We're going to send one algo to that address right here. We got to put in our password again. And momentarily, we will see that the transaction ID is created, and we can now notice that Bob's assets have gone down by 1, and our buddy Charlie now has 1 algo here. All right, so that's how you use AlgoSigner to create accounts and send some assets around. The other thing that you can do is opt into assets. So if we look at our Alice account here, we can see that she's already opted into a few assets as well as Bob, and we're going to use these a little bit later on. But our buddy Charlie hasn't. So if we take a look at an asset ID here, we'll copy it. And let's have Charlie opt in to an asset, which means that they're going to add this asset. So he's going to paste the asset ID and he's going to click on all. I guess I have taken an asset ID that I have deleted. How nice. Let me just grab one that I know is there. And how about this one? Yes. All right, we'll come back to that in a moment. Charlie, add address, put it in there, search for it. There it is. We are going to add this asset, put in the password because we have to sign that transaction. And here we are. That transaction has been sent, and it has a link here to GoalSeeker, which is PureStake's Explorer for the blockchain. So we can click on that, and we will notice then the couple of transactions that we have already done. Okay, this is the opt-in transaction for this asset. We notice that it's from and to the same person for an amount of 0. This means that they are now going to be able to use this in the future. And this was by our sender receiver. Okay, yes. So if we look here, now we can see those 2 transactions that we have done through the Algo Explorer, that we have done through the AlgoSigner have shown up here in the GoalSeeker block explorer. All right, that is a little bit about what we can do with AlgoSigner and how to do it. So let's bring back up that presentation and we will move on to what's next?
Got time for a question?
Yes, let's start.
Okay, yeah. Sammy is wondering about the audit trail for AlgoSigner. You heard there was one, and just wondering who does that. Do you happen to know, or I could research it if not.
I believe Trail of Bits did the audit on many of the Algorand products, but I don't know for certain. I do know that they have gone through the audit process. I just don't know who that third-party evaluator was, but I do think it's Trail of Bits.
Okay, I can pick PureSync. Thanks.
All right, you're welcome. All right, so we're done with that. So let's take a look at using AlgoSigner with ReactJS. So let's get into some interactivity pieces here. All right, so what we're going to do is minimize this out of the way. Good, and then we are going to take a look at an article here on the developer portal. And I want to remind you to always check out the Algorand developer portal. So that's developer.algorand.org. Here we have all sorts of great content for you weekly. We update this weekly. We've always got interesting new articles that are coming up. The best place is just click here to get started, and you're going to be in and understanding a lot of what we've already done in the previous pieces, how to set up your environment, how to send your first transaction, how to build your first application, how to build your first asset. All of that's covered in here, as well as more advanced articles like this one. This one's actually fairly beginner here, but this one here talks about what we're going to do today, which is integrating the AlgoSigner into a React website. So we go through kind of the very basics about how you may clone a repository that has this code that we're going to go through and take a look at, how you would configure your local environment with Node and Yarn, and ensure that you have AlgoSigner installed, of course. Get it started, and then we will go through and take a look at this demo site that we've got. So if we come over here, I've already got it running. So this is the first website that we've got built. And this is based on some work that one of my colleagues, Fabrice, did. He works at the foundation, and he built this React framework for us, or with this React website using the framework. And I wanted to extend it a little bit. It's also based on some work that PureSync have done. They actually have a wonderful website with an example here for this that is a little bit more involved than what I'm going to go through here. But let's keep it simple, and let's just take a look at what I built. All right, so we're going to show four different types of interactivity here. We are going to first of all have the web browser connect to the extension to check to see if it's there. So that's this button here. It's quite simple. It just returns that the AlgoSigner is installed. Of course, we know it's installed. If it was not installed, it would just give you an empty set. It would indicate that it would need to be installed. Next, this one is going to get the accounts. So we know that we have 4 accounts installed in Algorand, in the Algo Explorer, so in the AlgoSigner. So let's take a look at them. And we have first address, it starts with Alice. The next one starts with Bob. Then we have this AWC one, and then we have that I5A one here that we just created. So those are the 4 accounts installed in AlgoSigner. This is an interaction between the browser and the extension as well. The next one that we want to do is to get the transaction parameters. When we click this, it's actually going to go out to the network, and it's going to get data from AlgoD. And we'll take a look at what that looks like in the code momentarily. So we see the response back here indicating that we are in fact connected to testnet, and we are at around 14,200 or 14,200,000. The last one that we will do will be to check an application's global state. And we are going to take a look at this application ID here, 137. And we can see all of the data that is coming within this application. I know this application fairly well because it's our default counter application that we have as our hello world for starting application development. And here I can see that the value, the number of times that this application has been called is 32 times. So this counter increments every time that somebody calls it. All right, so that is making a call to indexer. So global state gets it from the indexer. Network parameters gets it from an AlgoD node, and then getting the accounts are actually just local, just to the extension itself. AlgoSigner is doing all of that for us and handling it. So let's take a look at the code here. So in my React project, I'll scroll all the way down the bottom and just show you that this is just a very simple container here, and all that it really has are those four components there to check the AlgoSigner, get the accounts, get the parameters, and get the global state. Very simple, but if we go in and look at the more interesting ones, which would be, well, I guess we'll look at them all. Let's look at the get accounts. So in this one here, we'll see that we are using AlgoSigner to connect to the testnet. All right, now you have the ability to connect it to Mainnet, and you would also have the ability to connect it to your other named instances if you have those installed. So I could change this to Sandbox because that's what I've named mine as well. What we're doing here is we are connecting first, and then we are going to make a second call to get accounts, right? So AlgoSigner implements a method called accounts, and as we saw, it returns back the accounts that are installed in it. All right, and then all we're doing is we're just sending that back to this component here to make it look pretty on the page. The next one is for parameters, and this one is using a slightly different call. So this time we are calling AlgoD, and we are passing it the path here to this endpoint. So v2 transactions params. And what's interesting here is that any of the v2 endpoints you can call through AlgoSigner just changing the endpoint here. And then you may handle the response in any way and incorporate it into your application. So we'll see that this is a common way to interface for some of our programming is to go to the AlgoD node. In the global state one, where we went to the application, we're making a different call here. And this time we're calling the indexer, right? So with this method, we are now passing the endpoint of v2 applications, and then we are sending it the parameter for the app ID, which we defined at the very beginning of this. So since this is my website, right, as the deployer, the maintainer of this website here, I have defined the application ID up here at the beginning. So I know every time that I load this page, I am getting the right application ID. As other times you may want to have it dynamic and be able to look at different types of apps, and you could do that as well. So that is kind of the introduction to the interactivity between the web browser and the plugin, and then also the plugin out to AlgoD and Indexer. Now we are going to change to a different one here. So I've got a different version that does a little bit more advanced stuff. So let me just reload it. And again, all of these are available for you on the developer portal, or you can link to them through the developer portal. I have links to them in the show notes. There'll be a link to the deck as well, so you can get this. All right, we're going to focus on looking at this application. On the left-hand side, we've got Alice, and on the right-hand side, we've got Bob. All right. So we saw last time, we saw earlier when we got the JSON response for that global state, that the global state was 32. So let's click get global state. Yes, nobody else has called it. All right, there it is. So this application has been called 32 times. That value is stored in the global state. We can also take a look at local state for each of these participants here. So if we take a look at Alice, she's called this 3 times. Now Bob, he's never called it because his response is empty. All right. So what we want to do is have Alice call it again. And this time that's going to prompt for our signature, or for Alice's signature. So this is what it says. This is for you, Alice, and it says that we have an application trying to call this. All right, so it matches, and it doesn't provide any arguments. It tells us how much it's going to cost, and then since it gives us a little warning because applications are a little bit weird and can do harmful things, so make sure that you're checking these out very closely. So in the detail, you can see that this is an application type transaction. It's from Alice. The fees, where it's going to testnet, all of the fields. So this is the unsigned transaction that the application has created, the dApp owner has created and presented to AlgoSigner for signature. I'm going to sign it, and I'm going to put in my password. And it's going to broadcast that transaction. So it sends us back instantly the transaction ID because it can calculate that based on that unsigned transaction, what that will be. We do have to wait for it to go and be processed about 5 seconds. And by now we should see that, yes, when we update the global state, it has been called one more time. I assume that was by Alice, right? Now it's 4, right? Okay, so Alice has been able to do that. However, over here, Bob has never called it before. And if he tries to call it right now, he'll see that and he'll sign it, and we'll get back a transaction ID, but it won't work. It's going to fail because he has not opted into this application. He doesn't have access to this application yet. So as I'm refreshing, you notice that the count is not going up. So another transaction type that we have here is the application opt-in. This is similar to what we did earlier with Charlie and had him opt into an asset. The AlgoSigner does not provide a user interface to opt into applications at this point, but we can do that here. So here we are saying, yes, do you want to opt into this application? Yes. And tells us how much it's going to cost. And again, we can look at the details of that. This time it's going to be from Bob, so he will sign that one. And when that then goes through, now I can call it. And I'm just going to sign it. We know what's going to happen. And momentarily, we are going to see then that the global state will update here. Just have to wait a little extra time, because really what's happening behind the scenes, the blockchain is faster than what's being displayed here. But I'm making a call to an indexer, which means that the block has to be produced on an AlgoD node and then observed by the indexer, queried, taken, and then written to the database. That's why that takes a little bit longer, querying an indexer, but it's only like, what, 10 seconds? It's still extremely fast. All right, so that's where we're at with the introduction to AlgoSigner and the interactions between it and a basic dApp. If you want a little bit more excitement, you can go to PeerStake, and they have also a very similar one. They actually show the code in line, and you can jump to it as well here, which is nice, so that you can see how they implemented it. They have the ability to do payment transactions, assets, as well as, I thought they had something for applications, but I guess not. All right. Then next, I'm going to pause here. Russ, how we doing?
Wow, they are very engaged.
I am thrilled. I'm thrilled.
I had a couple questions that you maybe can shed some light on MetaMask.
Do it.
Does MetaMask work on Algorand? No.
No, MetaMask does not have an extension for Algorand at this time. No.
Okay, and then the other one was, does AlgoSigner just work like MetaMask, but for Algorand? The just like part, I wasn't quite sure.
Yes, I would say that it is similar enough to say yes.
Okay, I know that's the analogy we give. So
Yeah.
okay.
Yeah, the important thing to understand about AlgoSigner is that it is a key manager, and it's holding your private keys inside of that web browser. When you clear your cache, it will go away. So that's why you have to maintain that mnemonic offline, so that when you reinstall your web browser, you can install your AlgoSigner keys back into it. The value is still there. That's why you must maintain your mnemonic. All right, let's move along, and let's try to do something a little bit more advanced by moving into an example dApp using some NFTs. All right, so what I have started to build here is called the AlgoWorld Swapper. All right, and the design, or what it is meant to do, is to be a provably fair escrow, where I have created a template contract, and I present that to everybody for verification, and then it will generate the brand new escrows for swapping two different cards between two different users. And then once that has completed, that escrow is no longer needed. But the design of this, although it's a centralized infrastructure, meaning that I have produced the code, I have produced the contract there, anybody can execute this. It is decentralized in its execution. If you trust the code that is published, then you can execute it locally if you would like. All right, so yes, AlgoWorld Swapper. The way that it is working here is that two different users, Alice and Bob, having each their own card here, are interested in swapping those. So they would come to the AlgoWorld Swapper website, and they would have reviewed the template here that describes what's necessary. So it will have things in there such as the address for Alice, the ASA that Bob has, and then a timeout period defined so that they could get their assets back if the other side doesn't participate before that timeout. That template then generates the actual escrow code here and replaces these template placeholders with the actual values in here. So in this case, we would see Alice's address, we would see the asset ID for Australia, and we would see a timeout as a block height. All right. Both Alice and Bob, once this contract is created, then both Alice and Bob will send their ASA into the escrow account. where it will be locked either until that timeout happens and then they can go and retrieve it, or until I or anyone creates a atomic transfer transaction that's grouped together that says, all right, Alice gets Bob's card and Bob gets Alice's card. That happens together, and they both they both go, or neither one of them goes. All right, so that's the design. Let's there they go, and then they will both go out. All right, so that is the idea. This is based on something that's actually running on Mainnet right now, which is called AlgoWorld and AlgoWorld NFT. So they've got a nice website, AlgoWorld-NFT.com. The author, Matt, he was on our developer office hours a couple of weeks ago, if you're interested to see kind of what that's about. But on the website, you can see that they have all these different cards here. They're actually still running a sale, but they have all these different cards here, right? Okay, so they're neat. You can check them out on Twitter. You can learn about it. These are what the cards look like. So here is the card number 1, Afghanistan, and it's got a fancy pretty border because it's the number 1 card of that group. Okay, so this is an NFT that is running on Mainnet. And the way that they did this was they, which is Matt, will take a look at what it looks like on Mainnet. Okay, so here is what was created here for one of these cards. So this is actually Italy here. So this is Italy. I'm sorry, this is AlgoWorld card number 670, which is Italy 9 of 17, and it has an asset ID here. Now, what's important to understand, because it's an NFT, is who was the creator of this one? Who issued it? How can we be sure that it's the genuine one and somebody hasn't just come here and taken a look at where the address for the file is located? As you can see here, if we copy this address and we paste it in here, we're going to get, apparently I didn't copy the right part. I got to copy the right part and then it'll work. Then we'll get that card to come up here. Okay, so this card number 670 has this URL on an HTTP server. It also has a reference to an IPFS address here, but I don't have an IPS browser installed here. This information is stored inside of a transaction that came from the creator. So that's how we know that it is the genuine deal. So we can see here, if we look at the creator's account, he's created 754 of these, and many of them have been sent because the amount is 0, and some of them haven't yet been issued, meaning that the creator still holds them and will be released in the future. All right, so what I did was to replicate a few of the cards that I actually own on Mainnet, and I made replica of them on testnet so that we could play around with the AlgoWorld Swapper as I built up the smart contracts. All right, so let's now take a look at some code that will have to do with AlgoSwapper. All right, one thing that I want to do here is, first of all, show you kind of what the idea of this looks like. So it's using an escrow contract that has 3 different scenarios plus a fee. And those scenarios are either opt-in both, because of course at the beginning, the contract has to be able to hold those ASAs. We know that we have to opt in to accounts, so we have to put that logic inside of the escrow account so a transaction can be sent from that escrow account so that it can approve those 2 asset IDs that it wants to hold. The second scenario is the time lock. This is the way for either party to get back their cards after a timeout period. And you can set the timeout to whatever the two of you agree on. The third scenario is the actual atomic transfer. That's where we're actually saying asset 1 from Alice is going to go to Bob, and asset 2 from Bob is now going to go to Alice. And then, of course, we put the fees in there just to make sure that nobody's spending too much. So this is the structure of it. Conceptually, that's what the structure of it is. We'll take a look at the actual Teal code briefly, but that's not, I'll show you the template, which I have documented here for us. The idea here is that we have these template values here. So we have the owner. So that would be me as the creator. So this address, remember we had that AWC, so that's the AlgoWorld creator on the testnet, that's me. And we have our other addresses, Alice and Bob, and we have the IDs of the two assets that we want to trade. So we're going to trade New Zealand and Australia, and we're going to set the timeout for block 1 for 14 million. That's actually in the past, and that's how I test, so that I never have to wait for it, and then I can get them back right away, just in case during testing. All right, so the code is documented here to go through each of the different scenarios, and I'm not going to focus on it because Teal's not the easiest thing in the world to read straight away. Let's take a look at the app that I built. Okay. All right, so we are going to put number 4 in here, and we'll take a look at what the Algo Swapper looks like, shall we? All right, so it should pop up over here. Yes, here it comes. Oh, you guys are going to be so impressed. There it is, the AlgoWorld Swapper. It's very much a work in progress. All right. On the left-hand side, we're going to choose Alice, and on the right-hand side, we're going to choose Bob. All right, so we've got the thumbnails of those two assets that we have. We've got this nice little thing here, so we can see that Alice has China and Netherlands, and Bob has Gambia and Australia. And they're interested in taking these two and swapping them between each other's. What they will do is first they're going to select to trade away and to receive back. So one person can do this side of it. We'll say that Alice can initiate this part and can actually make the escrow. The important thing after that will be that Bob then needs to verify that escrow to ensure that it meets that it compiles down to be the same code that they thought it was going to be. And of course, they both have to opt in to the new asset IDs that they have so that they can get it into their accounts. And then finally, each one of them will send their current asset into the pool, into the escrow account. And then on the back end, I will click the button to send the atomic transfer back to them. So what we're going to do is take a look at this in action. We're going to do part of it in the command line, and we're going to do part of it in the browser. So let me just make sure I've got my notes here. Make sure I know where I'm at here. All right. So. All right, so what we are going to do now is take a look at moving these assets back and forth. So I have this backend operations one here. There's another one here for how we actually issued them, but we are going to move towards the operations piece here. So the first piece that we want to do is to make sure that we create a contract to send these assets to each of them. So let's make, yeah, we know that if we check here, so Alice has 1587 389, right? So Alice has the Netherlands card right now, and Bob has the other one, the 1431 card, right? Down here, Australia. Okay, so they have those and they want to swap those. So behind the scenes, what I'm going to do is I'm going to use my escrow generator script, which looks like this, which simply takes the template file that we looked at earlier and it swaps out those values, right? So it's finding every place the template owner is, it's putting in the AlgoWorld creator. Every place for address 1, putting in Alice, and so on. So when we run that, we will get back a new contract. So let's run that down here. All right, and yes, okay. So now if we see what our contract is, it tells us that this address is now the escrow address for where both Bob and Alice are going to send their cards to. So the first thing that we need to do is to construct that opt-in. All right, so this is going to send the, it's going to create an unsigned transaction group them together, split them apart, and then ask both parties to sign them. I'm sorry, not both parties, to ask the escrow contract to sign it. And we are going to sign it with the actual Teal program here. So the source code itself is providing the signature, the authorization for approving the transactions to opt in. So let's just do that. Let's just run that through here real quick. And then we're going to have it signed with that code. I'm stopping it here in a dry run. I just wanted to note that it does pass. Now we're going to send it. So we're going to wait for that, those two transactions. It's an atomic transfer to be sent, broadcast to the blockchain. We will note now that those two asset IDs are now opted in by this escrow account. So that part has worked. The opt-in worked. We're now ready to have Alice and Bob send their assets into the escrow. Oops, let me copy the escrow address so we know where to send it. So if we come here and we'll just use this here to, oops, to send one, we are sending the Netherlands to the escrow address. So that was Alice. And then we'll do the same thing for Bob. Back up as Bob and send one Australia. Also there. All right, now we will come back here and take a look at that again. Now the escrow account has one each of those assets. So Alice and Bob have successfully sent it, locked it away. Now the only way to get them back out is to send a transaction to group together to meet the second, actually the third, I closed it, to meet that third criteria, which was the atomic transfer. Okay, so we're going to do that here. So we are going to build two different unsigned transactions. This time we are saying that Bob is going to get one asset ID and Alice is going to get asset ID 2. So that means that they're going to perform the swap. All right, so we're going to concatenate those together, group them, split them, and then ask them each to sign them. Well, no, we're not asking them each to sign them. The escrow contract is signing them. I'm sorry. So they are now we are going to have the signature here, and we're going to stop it again in the dry run. Yes, it's going to pass. And now we are going to send it away. One transaction. So this is the signed transaction group that has both of those transactions, both of them having the signature of the escrow teal. Here we go, sending those through, and then we'll get the response back, and we would expect that they will be empty. Yes, and we will see then that in here, Alice now has Australia and no longer has the Netherlands here. It's still there because she still opted into it, but the value is 0. And then of course, the same thing will be true on Bob's side. So he now has the Netherlands and does not have Australia anymore. So that is what we wanted to accomplish here today with the, come on, AlgoWorld Swapper. And we've gone over now this interactivity piece. We've got, so we've been through it all, right? So we wanted to understand how could we use AlgoSigner to interact with our web browser itself, to interact with our, I'm gonna stop sharing here so I can see you guys. All right, let's do this. All right, so we wanted to be able to have AlgoSigner work with a web browser, work with a dApp, and then also to create a dApp that was then able to use both smart contracts and NFTs together. We put them into an escrow. We ended up using Teal to sign those escrows, and then we also used the AlgoSigner in order to move the assets around as well. So this is kind of that capstone of all of the stuff that we've covered in our previous weeks. And we want to make sure that we're helping you guys build these types of solutions on top of Algorand. This is just a brief overview of what you can do. I know it was quick. I know that this will be recorded, and I want you to go back in and see it. Again, I will post the code so that you guys can go and try it out as well. Build your own swapper, build your own NFTs. We've got all sorts of great resources out there for you to do that. Most of that is going to be found at developer.algorand.org. We are always on Discord. We want you to come there. That's in the footer of our homepage on the developer portal, as well as a link to our newsletter. Make sure you guys are connecting with us. We're here to help. So I've got some time for questions then.
Yeah, that was a lot of questions we had, but I think we got them all. I was also pinging Tim on a few of them, so we got some answers there. Also, Tim wanted to make sure that everybody knows that they will be monitoring the Encode channel. If you have any more, that's on the Algorand Discord. So if any follow-up questions, feel free to ping in there, and they'll be looking at that as well. And as far as I just got a question, any new features coming to AlgoSigner soon? I think the latest status it just got, like I posted in there, is they're updating the January V2 branch today with pre-reviewed code for the V2 signing. And that's the latest update I have. I don't know, Brian, if you have anything newer on that.
I can't add anything to it. I know Tim and the team there at PureStake are doing a wonderful job on the AlgoSigner.
If I missed anybody by mistake, just speak up right now, unmute your mic. I think I got everybody, but I wanted to give people an opportunity to make sure or if you have a new question you just want to ask verbally, that's fine too.
Just quickly, Ryan, as well, I had one, I'm not sure if we covered it, but does AlgoSigner work with Ledger or any of the hardware wallets at the moment?
Does not at the moment, but that is a feature request that they are very much interested in. I will let you know that we have two other major wallets in the Algorand ecosystem. So there is My Algo Connect, which does have Ledger support, as well as, of course, the Algorand mobile wallet, and that also has the Ledger support.
Yeah, and that is another option. You went over the Algo Key utility, also Algorand Wallet, right? You can download that. You can create accounts and get, your passphrases and stuff like that as another alternative for those that are more GUI inclined like me.
Yes, absolutely. And we spend much more time inside of the graphical user, or not as much time for the graphical user interface, and more time with the CLI. That's for sure.
Yeah, and Tim says they're working on the Ledger support now.
Great.
Fantastic.
So, yeah.
Awesome. I'm not sure there's been any more questions. Thank you very much, Russ, as well, for answering those questions throughout, and obviously to Ryan for the fantastic talk. Very informative, and it's kind of a pleasure to have you guys every other week. In terms of upcoming events, we'll be having kind of posting about the next set of events, hopefully later this week. So keep your eyes peeled in the Discord and on the Encode Club Twitter for that. But yeah, thank you very much. Just a reminder that this whole education series is gearing up to the Algorand Hackathon, which we'll be hosting in July. So you'll be able to build your own cool projects in Algorand, hopefully win some prize money. And then following that, there'll be the Algorand Accelerator starting later in the year to take the top projects from that hackathon and take them for a 10-week accelerator to get them to the stage where they're either ready to raise funding or ready for a grant from the Algorand Foundation. Thank you very much, and I hope everyone has a great evening.
Okay, great, thanks.
Thanks very much.